Okay, folks, our second topic here in our unit on proportional reasoning. We're still talking about rates, but we're going to talk about rates and graphs and how all that stuff fits together. All right, so we're going to look at constructing graphs that can represent rates and interpreting the slope of the graph as a rate and how those two things are connected. So let's get started. It says for this first scenario, we've got Sarah and Jessica leaving Gander in separate cars, and each one has a full tank of gas. When they arrive in Corner Brook, which is 368 kilometers distance, they each fill their tank. Sarah's car needed 25 liters and Jessica's car needed 20 liters. Okay, so we get fuel required. The biggest number I see there is 25. So 1, 2, 3, 4, 5. We'll call that 25 liters right there. So up the top, that'd be like 30 liters. And that means we've got sort of 5 liters per block on the vertical axis. And we've got 368 kilometers, so let's go 100, 200, 300, 400, call that 500. And then 368 would be somewhere in this vicinity, a little closer to 400 than 300. All right, so we want to draw a graph for this. So for Sarah, she started off, no gas used when 0 kilometers were traveled. And the only thing we really know is that at the end of her trip, she's traveled 368 kilometers and she's used 25 liters of fuel. So that would put another point here. And then we have to do our best to draw a line that connects those. So this won't be a perfectly straight line, but you get the idea. And then for Jessica, it's the same idea, only she only uses 20 liters of gasoline on the same distance for her trip. So we're going to draw that. I wonder who got there first. Who's faster? Doesn't really matter. All right, so the first one was for Sarah. And the second one was for Jessica. Okay. And next what we're going to do is we're just going to look at the numbers from the scenario and we're going to calculate their unit rates. And then we're going to compare those unit rates to the slopes we get for the graphs that we drew. So for Sarah's unit rate, she used 25 liters over a span of 368 kilometers. So Sarah's unit rate that we calculate there is going to turn out to be about 0.068 liters per kilometer. Okay, 0.068 liters per kilometer. Gotcha. And then for Jessica's unit rate, same distance, different amount of fuel used. So it's 20 liters per 368 kilometers. So if we simplify that, or just divide the two, we've got 0.054. And that's also going to be in liters per kilometer. Okay, so we can see that Jessica's fuel consumption is less, which is good for Jessica, but we knew that because she only burned 20 liters instead of 25. Now we're going to look at the slopes of those two lines. Okay, so for Sarah's line, we're going from a point down here at 0, 0, and we're going up to a point up here that has coordinates of 368 horizontally and 25 vertically. And for Jessica's line, we go 368 horizontally and 20 vertically. Okay, so slope is rise over run. So for Sarah's line, going from 0, 0, we go up 25 and we go over 368. And you'll notice that that's the same ratio we had before, and it'll give us the same number, 0.068. Okay, and then for Jessica, her slope, rise over run, is going to be up 20 and over 368. So that's going to be the same number we had for that one before, 0.054, and those would be in liters per kilometer as well. But what we want to notice here is that the slope of each line corresponds directly to the unit rate. And as long as it's a straight line, that's going to be true anywhere on the line. Or if it's not a straight line, we'll talk about sort of average unit rate, and then that would be the same anyway. So what we notice is that the slope of the line is actually equal to the unit rate. Okay, so the slope is equal to the unit rate. How does that help us? Well, what it does is it allows us to draw a graph to compare these things, or two graphs in this case. And without even doing some calculations, and if these numbers were a little less, or not quite as easy to figure out, like 20 and 25, or if we had some numbers where the points were all over the place, we'd be able to tell from the graph different areas where the slope was steeper or less steep, and that would tell us whether we had a bigger rate or a slower rate. So steeper, faster rate, less steep, slower rate, and that's easy for us to tell. We knew that Jessica had better fuel economy, and her line right here is not as steep as Sarah's was, right? So Jessica had a lower slope, better fuel economy, burning less gas. Okay, let's look at this one. The graph shows the world population of people of European descent since the year 1700. Determine the average slope of the graph between 1800 and 1900, as well as between 1900 and 2000, and use these slopes to describe how the population is changing. Okay, 1800 to 1900, we're going to go from, I guess that looks like about 23, maybe 22, up to, looks like maybe 31 here, because remember there's only 5 units in between each one. So let's say this one's at 22, and we'll say this one's at 31. Okay, and those are at 1800 and 1900. So if we do that interval first, so from 1800 to 1900, we're going to find the slope. So we're finding the slope basically of what we call a secant line, or an average slope for the graph. And that's going to be the difference between those two y-coordinates. So 31 minus 22 will be your rise, over 1900 minus 1800 will be your run. And if we plug and chug at that a little bit, we get about 0.09. And that's going to be percent for the vertical unit and year for the horizontal. So what that tells us, since it's a positive number, it means that the relative percentage of people in the world who are of European descent was actually growing compared to everybody else put together at 0.09% per year. So less than 0.1%, but it was growing. Let's look at 1900 to 2000 now. So if we look at 1900 to 2000, I'm going to put a dot over here, and that one looks like it's got a height of about 17-ish. Okay, so for that one, if that's got a height of 17, then we're going to take the slope of that, which will be 17 minus 31 over 2000 minus 1900. And that's going to give us a negative number this time, and it's going to be about 0.14% per year. And what does that mean? It means that after 1900, or from 1900 to 2000, the percentage of people in the world who are of European descent was declining by about 0.14% per year. Okay? So lots of interesting stuff there. So the key thing is that the slope represents the unit rate. Steeper slope, higher rate, less steep, less rate. Thanks.